to discuss some more function, that is divergence and curl of vector point function. Okay, so divergence and curl of a vector point function. Given any vector point function, we can define what is curl and what is divergence. But for scalar point function, we have a gradient. So definition. So definition for divergence. Suppose you have a vector point function called f. So let f vector at a point x, y, z. Let f be a vector point function. Okay, it is differentiable. Okay, the function should be differentiable. Now the divergence of then the divergence of f. Sorry, divergence. Divergence of this vector point function f dash is defined by del dot f dot product. Okay, therefore there should be scalar. Okay, delta of f should be scalar. So where what is actually del dot f? So del is an operator. So del dot f is nothing but, so del is an operator, I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z dot product with the f vector f. Okay, so that means what? You have to operate the vector each thing, that is I vector times dou f vector by dou x plus j vector times dou f by dou y, and then k vector should be dou f by dou z. So that is the thing. Actually, suppose actually this is dot. Okay, so keep in mind this is a dot. Suppose f is again, since f is a vector, therefore we can write xi vector plus yj or f1 f2 f3 is the component of the vector f. Suppose f equal to f1 times I vector plus f2 times j vector plus f3 times k vector. Now what is the divergence? The del dot f is nothing but, just you have to differentiate f1 with respect to x, and then sum with the differentiate f2 with respect to y plus dou f3 by dou z. Just you have to differentiate and then sum. So this is a divergence of the vector point function f. Okay, so here actually dot product. Term by term you have to multiply, differentiate and then add. So this is a divergence of f's, or very simply we can write this is a divergence of f. So this is equal to, sometimes I div of f vector, divergence of f is del dot f. Suppose the del dot f is 0, then we say the vector is solenoidal vector. Okay, solenoidal vector is, the del f is 0. So definition, solenoidal vector. So when we say a vector is solenoidal vector, if the del dot f is 0, so if f is a vector point function, is a vector point function such that the del dot f, that is the divergence, is 0, such that the del dot f vector is 0, then f is called solenoidal vector. Then the vector point function f is called solenoidal vector. Okay. Now the next definition, curl of a vector point function. So next definition, curl. Suppose you have a vector point function f, then what is the curl? So if f vector of x, y, z be a vector point function, and it is differentiable. Okay, without differentiable we cannot say. Okay, so it's a differential function also. Then the curl of f vector is defined by the vector product of del and f, that is del cross f vector. Okay, so this is a curl. So we denote just this is nothing but curl of f vector is del cross f. So you have to take the vector product of these two vectors. So actually there is a theorem. So this del cross f is nothing but a determinant of the matrix. So del cross f is nothing but the determinant of 3 by 3 matrix. The first row is I vector, j vector, k vector, and the second row dou by dou x, dou by dou y, and dou by dou z. And then the last row should be the coordinates of f. Suppose f1, f2, f3 is the coordinate, then f1, f2, f3. So the determinant of this matrix is the curl. So what is the determinant actually? Equal to I times, if just cross multiply this, dou f3 by this minus this one. So dou f3 by dou y minus dou f2 by dou z, and then minus j vector into, and remove this second column. Therefore dou f3 by dou x minus dou f1 by dou z plus k vector into dou f2 by dou x minus dou f1 by dou y. So this is a curl of a vector point function f. Okay, now suppose this curl is 0, then we say is irrotational vector. A vector is said to be irrotational, the curl is 0. So the next definition is irrotational vector. So what is the definition? Suppose f is a vector point function, the curl is 0, that is if the curl of the vector, so curl of the vector is nothing but del cross f. If the del cross f is 0, then f is called irrotational vector. F is called irrotational vector. If divergence is 0, that is called solenoidal. If curl is 0, we say it's a irrotational. Okay. Now we solve some problem to find the curl and divergence of a function at the point. So exercise. So suppose if f vector is xy square times I vector plus 2x square yz into j vector minus 3yz square times k vector. Okay, now find divergence of f and curl. curl. Okay, and what happened at the values at the point 1 comma minus 1 comma 1 at the point, what is the curl and then divergence. Okay, so what is the value of divergence of f, curl of f at the point 1 minus 1 1. So simply what is first you have to find what is divergence of f. So divergence of f is nothing but just you have to differentiate the first coordinate, that is f1, this is f2, this is f3. You have to differentiate f1 with respect to x, plus you have to differentiate f2 with respect to y, plus you have to differentiate partially with respect to z of f3. So therefore, if you differentiate partially, we get y square from the first term, plus if you differentiate with respect to y, we get 2x square z, and then minus 6y z. So this is del dot f. So at the point 1 minus 1 1, substitute x equal to 1, y equal to minus 1, z equal to 1, we get 1, and then plus 1 into 2 minus minus plus 6, therefore we get 9. So at the point 1 minus 1, the divergence is 9. Now what is the curl? Curl of the vector f is del cross f is nothing but determinant of the 3 by 3 matrix I, j, k, dou by dou x, dou by dou y, dou by dou z, and f1. What is f1 is xy square. So xy square, and f2 is 2x square yz, and f3 is minus 3yz square. So that is a curl. Now if you expand via the first row, you will get I vector times, if you differentiate this partially with respect to y, we get 3 minus 3z square, minus if you differentiate this with respect to z, we get 2x square y, minus j vector times, if you remove the second column and differentiate x, we get 0 because there is no x here, and then differentiate with respect to here, again we get 0 because here there is no z. Now plus k vector times this into this. So if we differentiate with respect to x, we get 4x yz, with respect to y we get 2xy. So therefore there is no z term. If you want, you can take minus outside, 3z square plus 2x square y times I vector, and then plus 4xyz minus 2xy times k vector. So this is a curve. Now at the point 1 minus 1 1 is, so the curve at the point 1 minus 1 is, so therefore we get a minus of 3, and this is minus 2 times I vector, and here plus minus 4 times plus 2 times k vector. So this should be minus I vector minus 2 k vector. Okay, so this is a curl of a function at the point. Okay, okay. Maybe they will give some function with unknown values of a. Suppose they given that curl is irrotational, we have to find that value. So maybe I give one problem, you just try. So maybe the question may be asked, find the value of a, find the value of a such that the function f vector equal to axy minus z square into I vector plus x square plus 2yz into j vector plus y square minus axz into k vector. Suppose this vector is irrotational. Now find the values of is irrotational. So find the values of a such that the function is irrotational. So irrotation means what? We have to take this del cross f is 0, and then from this you got to find the values of a. If you find this, you will get I think a value is 2. Okay, so just to find the expand the determinant, and then you can compare the thing. You will get a equal to 2. Okay, so 0 means what? It's a 0 vector. So actually 0 means what? It's a 0 vector. 0 times I vector plus 0 times j vector plus 0 times k vector. That is 0 vector means actually it's actually 0 vector. So you can find the values. So some problems they will ask like that. Okay, and there are some properties between these three function: grade, curl, and then divergence. You just go through it. If you refer it books, you will get something. Maybe some of them maybe I will mention. So if you take del dot del pi, so actually this is gradient, and this is, if you take dot, this should be divergence. So actually similarly simply we can write this is divergence of del pi. This is nothing but del square pi. Del square is equal to dou square by dou x square plus I j vector into dou square by dou y square, second derivative, partial second derivative, that is del square pi. So del dot del pi is nothing but del square pi, and if you take curl, that is del cross del pi is nothing but curl of del pi, because vector product is nothing but curl. So del cross del pi is nothing but 0 always. Okay. Now the third one, suppose del dot del cross f. So this is dot, therefore is divergence of, but what is this? Curl of f is nothing but 0. So similarly here we can write actually del pi is nothing but gradient. So therefore divergence of gradient of pi, it should be del square pi. So again this curl of del pi, but del pi again divergence, therefore curl of gradient of pi should be 0. Okay, and then curl of divergence curl of f is 0. Suppose the next one is everything is Cartesian product, so that is del cross f. So this is nothing but curl of f. It should be del of del dot pi, sorry, del dot f minus del square f, where f is a vector point function. So these are all important things. You can easily prove it. Okay, just by apply the definition, you get the answer. Okay, then you can look at you can go for integration, vector integration. So far we discussed about differentiation and then continuation of a vector point function or the vector f or r. Now what is the integration of r? Okay, how to define the integration? So next we are going to discuss vector integration. Okay. So suppose we have a two vector find function small f and capital F, and then we know about the derivative, right? Suppose we have a two if f of small f vector of t and capital F vector of t be two vector point function. Suppose we have a two vector point function, and already we discussed about the derivative of vector point function. So vector be two vector point function such that functions such that the derivative of one function is another. So such that suppose the d by dt of capital F, you get another vector point function small f of t, then we denote this capital F is integration of this small f. Okay, otherwise sometimes called this capital F is called the integral of f. Then this f capital F of t is called the integral of f, integral of small f, integral of f of t with respect to t, with respect to t, and is denoted by and and this is denoted by just integral f small f of f vector t is nothing but capital F of t. So in general, even if you add with the constant, because the derivative of this constant is 0. So in general, the integral or the derivative, okay, the derivative of f of t plus c. Not suppose if you know the derivative of capital is small f, even if you add some constant to this capital F, that is capital F of t plus some constant c, still you will get f small f vector of t. Like if you know the capital F derivative is small f, if you add with the constant, still that f of t plus c is also the integral of f of c. Therefore, in this case, we denote the integral value is integral f of t into dt is f of t plus the integrating constant. That's why we say we are adding some constant. So this capital F sometimes called actually indefinite integral of small f. Okay. So this capital F is called indefinite integral. Okay. So if you differentiate, you will get the given function. That the function is called indefinite integral. Okay. So now the f vector capital F vector of t is called an indefinite integral. Is called the indefinite integral of f of t. And even you can take not only c, actually we can add two vector, right? So therefore actually this is some vector. If we take some constant vector, okay, because we are adding two vectors, not for constant and vector. The way this c may be constant vector. So constant vector means what? The coefficient of I is some number, 2 or 3 or something. It's not a variable. But in the f of t, the coefficient of I are some function of t, coefficient of j are function of t. But the c is nothing but some constant vector. All the coefficients should be constant. So this capital F of t vector is called indefinite integral of f of t, and the c vector is any arbitrary constant integration. So is an arbitrary constant integration, constant of integration. and there should be vector, but it should be constant vector. Okay. So as we see in the real case, suppose is bounded, the vector varying function defined definite integral means what? If you know the limit, lower limit, upper limit, such an integral is called the definite integral. If such is at least one of the limit is variable or no limit is given in the integration, such a limit such an integral is called indefinite integral. So look at here, there is no limit here, integration. So just integration. That's why we call it a indefinite integral. Suppose if you know the both upper limit and the lower limit of integral, such an integral is called a definite integral. Okay. So if you know the integral, the upper limit, lower limit of the vector valued function, therefore integral a to b f of t dt is nothing but just we have to take the, because integral nothing but f of capital F of t plus the c vector, and you take a to b, so this is nothing but f of b minus f of e, f of b vector minus f of e. If you know capital F is an indefinite integral, so that is the capital derivative of capital is small f. This integral a to b f of t dt is f of b minus f of a. Otherwise, simply suppose if you know the f of t, suppose the small f, the vector f of t, suppose it has some components, some we can suppose f1 of t into I vector plus f2 of t into j vector plus f3 of t into k vector. Now, what is the integral a to b f vector of t into dt? Just integrate term by term. So integral a to b f1 I, we can take I outside, okay, because f1 of t into dt plus j vector times integral a to b f2 of t into dt plus k vector times integral a to b f3 of t. You have to integrate term by term with respect to t. That is the integration if the limits are known, the finite value a b. Okay. So maybe I'll leave to the exercise. Maybe there are some exercise there to find the integral over the range 2 to 3. So maybe I write, so find integral 2 to 3 f of ft, where what is the function f, the function vector is 3t square minus 1 times I vector plus 2 minus 6t into j vector minus 4t k vector. Okay, you have to integrate term by term and then substitute upper limit, lower limit, you will get the answer. Okay, now we have discussed about line integral. Suppose you want to find the integral over the line. So the next we are going to discuss line integral. Okay. So along the line, what is the integral? So we have to evaluate the integral along the line, that is called a line integral. So that is definition for line integral is any integral which has to be evaluated, along the line, which has to be evaluated along a curve, any curve along a curve is called a line integral. Not only because line itself is a curve, but if you integral over any curve, that is called a line integral. Okay. So how to solve this one? How to find the integral for this one? So maybe I can directly write the thing. Suppose it's given that some vector valued function. Suppose f, capital F or anything. Suppose we take capital F of t equal to some vector, maybe some f1 of t into I vector plus f2. Maybe you can take f1, f2. No need to write. It's a function. It's always function of t. So mandatory. Okay. So f1 times I plus f2 times j plus f3 times k. Or simply we can write in the order triple just f1 comma f2 comma f3. That is the meaning actually. The first one is the coefficient of I vector, second one is coefficient of j and so on. Suppose this is a vector point function. So let f of ft, f of t is be a vector point function. Vector point function defined along a curve. The function is defined along a curve C. Okay. So the C may be anywhere. Okay. So from each point of the curve, we have a function that is f of t. Now suppose let fr be the position vector. Suppose let r vector, we can write xi vector plus yj vector plus zk vector be a position vector of any point on this curve. If you take any point on the curve, the position vector we can call r vector. So be the position vector. Position vector of any point on the curve, on this curve C. Now I am directly write the formula for a line integral. So just you have to dot product with this dr. So if you know r, we know what is dr. Dr is nothing but dxi plus djj plus dzk. So that is dr. And if it is suppose with respect to arc length, you'll get something. Okay, so directly you can write. So integral over along any line a to b. Okay, f vector dot dr vector by ds into ds. So this integral is called the line integral of f along c. Is called the line integral. Line integral of capital F along the curve c. Along c. So the integral also called the tangential line integral of f. Also called. So this integral also called, the integral is also called the tangential line integral. Tangential line integral of f along c. Along the curve c. So either we can call just line integral or tangential line integral of this one. Okay. So actually note that if you cancel this ds is simply nothing but f dot dr. Okay, over the curve. So note that the integral a to b f vector dot dr by ds into ds is nothing but just the integral a to b f dot dr vector. This is the line integral. Okay, maybe there is some theorem. What is the necessary sufficient condition for the integral a to b f of f dot dr to be independent of any path is that the gradient is f should be gradient of some function, then the function is independent of the path. Okay, so that is a theorem for line integral. That is important theorem. So the theorem is called the theorems on line integral, the first theorem. So necessary sufficient condition, that is if and only if. So the integral is independent of the path a joining b is that f should be gradient of some function, scalar value function f. So the statement is the necessary and sufficient condition. Necessary and sufficient means what? If and only if actually. So necessary and sufficient condition for the integral a to b f dr f vector dot product dr vector b independent of the joining of the independent of path joining a and b, because if you give any 2 points a and b, we have so many path we can reach this two, we can connect these 2 points. Okay, so suppose we have a and here b, either we can connect, we can join by either line or some curve. If you take anything, the integral value is independent of this path only when that capital F should be gradient of some function. So path joining a and b is that the capital F is gradient of some scalar value function, that is that capital F should be del pi for some scalar point function pi. If the capital F is gradient of some scalar value function, that this integral is independent of any path. If you take any path, the integral value is always same, provided that F should be gradient of some scalar value function. So this is an important theorem in this line, is integral of line, one of the important thing. Okay, now we solve some problem to find the integral along some curve. Okay, so exercise. Suppose if f equal to 3x square plus 6y into I vector minus 14yz into j vector plus 20xz square into k vector. Okay, evaluate integral f dr from the point 0, 0, 0 to 1, 0, 0. So we can this is a equal to 0, 0, b equal to 1, 0, 0, but we can reach these 2 points so many ways. Okay, along so many paths. So along the following paths. So along the following paths. For each path, we have to find the evaluate the integral. So the first path is if x equal to t, y is t square and z is t cube. And then second, the straight lines from 0, 0, to 1, 0, 0. So we can directly reach the point via the straight line. Then if you take the point 1, 1, 0 and then 2, 1, 1, 1, then what is the integral? Via straight line. Okay. So the third path is the straight line. That is this one is a direct line. So straight line joining the point 0, 0, 0 and the point 1, 1, 1. So now we have to evaluate f dot dr, and then for each path we have to evaluate the integral. Okay, so solution. So first you have to write what is f. Is given that f equal to 3x square plus 6y into I vector plus minus 14yz into j plus 20xz square times k vector. So this is f. Now usually we take the position vector r is xi y x y z. So we take the position vector r is xi vector plus yj vector plus zk vector. Now what is dr? So dr vector is nothing but just the differentiation, that is dx times I vector plus dy times j plus dz into k. Now what is f dr? F dot dr. You have to term by term, you have to multiply. Therefore, we have 3x square plus 6y times dx plus minus 14 yz into dz dy plus 20 x z square into dz. So this is f dr. Now we have to take the first you have to take x equal to t, y equal to t square, z equal to t cube, and then find the integration. So first you have to take x equal to t, y equal to t square, and the z equal to t cube. Now what is dx? dt. If you differentiate both sides with respect to t, so what is dy? 2t dt. What is dz? 3t square into t. So now everything in terms of t. So therefore, so then we moved the points. Actually, we are moving these points, these two, the point 1, 1, 1. Sorry, yeah, because so actually what we have to move from 0, 0 to 1, 0, 2. Okay. Now, what is the value for t? Is always, if it is x is 1, then if it is because if x is 1, then t should be 1. Therefore, y should be 1, z should be 1. Actually, when the points move from this to this, then t varies from 0 to 1. Okay. So now what happened? the first time. Therefore, integral over C, integral over the path C f dot dr. You have to replace everything in terms of t. Okay, so therefore this is integral, everything is t, therefore t varies from 0 to 1. You substitute x equal to t, we have a 3t square plus 6 y is t square times what is dx is nothing but dt minus 4 times y is t square, t z is t cube, dz is 2 times t into dt, and then the last one is plus 20 t, t square, z square is t power 6 and dz is 3t square dt. Anyway, you can take dt outside and then simplify, finally you will get integral 0 to 1. If you add this, you will get 9t square minus 28 t power 6, okay, plus 60 t power 9 into dt. So if you integrate with respect to t and then substitute 0 to 1, you will get actually 5. So along this straight line, you will get this one. Now the next part, along the straight line from 0 to 0012 002 1000, then x, here only x is varying, all others are 0, so therefore only x varies from 0 to 1 and y and z are 0, so y is 0, z is 0 in this case. Besides z and y, the second coordinate, third coordinates are not varying, only the first coordinates are varying. So therefore you have to substitute y equal to 0, z equal to 0, so what you will get? Therefore since y equal to 0, therefore dy should be 0 and then dz should be 0. Therefore integral f dot dr vector is only dx. So look at here, so here this term is 0, okay, this term is 0, this term is 0 because dy d is 0. Here y is 0, therefore only we have a 3x square dx. Okay, so therefore this is nothing but just the integral 3x square dx, but here x varies from 0 to 1. Therefore this is x cube by 3, 3 cancel, we have x cube. If substitute upper limit, we get 1. Okay, so what is the next thing? Along the path, so now we did this one. So from this to this we find, and then this to 110. Okay, therefore 100.2, another point is this one. So here x is fixed, okay, x equal to 1, but y is varying from 0 to 1, z is 0, and then last one is from here to here. So here only z is varying, x equal to 1, y equal to 1. So similarly we can find the another path. So along the, you can from this point 0 1 0 0 2 1 comma 1 comma 0. So in this direction, since x equal to 1, but y varies from 0 to 1 and z is 0. So anyway, what is dx is 0, dz is 0. Therefore integral f dot dr. So in the first x, you have to substitute x equal to 1. So here, so here y is varying, anyway this, but dx is 0, therefore this term is 0, and dz is 0, this term is 0, only this term. So here y is varying 0 to 1, but z is, I think, what is that, z, I think 0, therefore simply we have 0, because it is 0, therefore simply we get 0. Integral 0 dy from 0 to 1, but anyway this is 0. So after that, from this point 1102 to 111. So from next one is from the point 0 comma 02 111. So here x is 1, y is 1, but z varies. from 0 to 1. Therefore dx is 0 and then dy is 0. Therefore first two terms are cancelled, only the last term. So in the last term we have a x is there, therefore x is 1. So 20x z square, 20x z square. Therefore integral f dot dr is nothing but integral z ranges from 0 to 1, 20x z square, I think so, into dz. So here x is 1, therefore 20 z cube by 3, 0 to 1, therefore just 1 by 3, therefore 20 by 3, I think 20 by 3. So now therefore you have to add all the things. Okay, so therefore so what is the question actually? So first is move from this point to this point and then this point to this point. So maybe you can take 3 points. So this is 0 0 0. So from this point to 1 0 0 0, and from, so first you have to move this direction. So from these 2 points we have another one is 1 1 0. So after that it moves the point 1 1 1. So we know the value of this and we know the value of this, we know the values of this. Just sum, you will get a integration over this point to this point. Okay, along this direction. Anyway. So similarly the last one is here x, y, z are vary. Both are, we can take t. Okay, t is the variable. T varies from 0 to 1. You can simply solve it. So therefore given any curve, we can find the integration. Maybe we can solve one more thing. If we take any different curve, how to find the integration. Okay. Now next to the problem. Suppose find the total work done by the force given by the element. So anyway, so F is 3xy times I vector minus 5z times j vector plus 10x into k vector along the curve x equal to t square plus 1 and y is 2t square and z is t cube. So along this direction from the point from the point 1 to t equal to 1 and t equal to 2. So how to find this one? So again you have to find the FDR. So f vector dot, you can take r equal to x y z. So you have to take the first coordinate 3xy into dx minus 5z into dy plus 10x into dz. So this is FDR. If you take the integral, you can take the integral. Now you take the curve. So it's given that x equal to t square plus 1 and y is 2t square and z is t cube. Now differentiate. Therefore dx should be 2t into dt and dy should be 4t dt. dz should be 3t square dt. Now substitute everything in this f dot dr, everything become this one. Therefore integral f dot dr vector over the curve is integral, if substitute x equal to t square 1 and then all the things. So finally maybe simply you can write. So here what is the variation? Maybe you can write. So simply 12 t power 5 you will get plus 10 t power 4, if you write in the decreasing order, plus 12 t cube plus 30 t square into dt. So after substitution, you will get this thing. Now t is varies. Now everything is t is given that t varies from 0, 1 to 2. It is given in the problem. So along the curve from t equal to 1 to 2. Now if substitute, so the lower limit is 1, upper limit is 2. Now if you integrate and then substitute the value, you will get. So I directly write 303. Okay. So this is a integral along the curve. Any curve we can find it. Okay, so maybe the next maybe in the next class we will discuss about surface integral. Okay, now I stop.